Hello everyone. Thank you for coming back to the channel, and I hope you guys are learning from every video that I'm posting. Please, if you are new, don't be scared to hit the subscribe button and the notification bell so that will get the videos whenever I post them. I post videos every day. Videos every day, and I hope you guys will keep learning. Today I'm about to do question 6, question 7 and 8 of the KZN June examination. Together, it just focuses on Euclidean geometry. Please listen attentively. If you don't understand, you can email me at mlungisimanana@gmail. No, it's mananampumelelo rather. mananampumelelo@gmail.com. Manana at gmail.com, ne? Or you can send me a WhatsApp on 065 886. If you don't understand whatever I said, you can send a screenshot of the part you don't understand here or on my email or on my WhatsApp. Together. If you wanna ask more about extra lessons for maths and physics, I'm available too. Okay, let's work. Question 6. I'm told that SR is the diameter of the circle in the sketch below. Okay, immediately when I'm told about the diameter, two theorems should click into my mind. Is that a diameter should subtend an angle of 90 degrees at the circumference. Another one is that a diameter is always perpendicular to a tangent. Are you together? So I know this should be 90. If PR is a tangent, that means it should be 90 even here. So what did they say? PR is a tangent to the circle at R. Okay, we just indicated. Already we have seen two theorems. First one, angle in a semicircle, hence T1 is 90. Second one, the relationship between the tangent and the diameter, they're always perpendicular. They give an angle of 90 degrees. Okay, we are also told that SV is produced to meet PR at Q. TV and TR are drawn. TV, okay, those are just codes. Write down the reason the size of angle PRS. Angle PRS is 90 degrees. And the reason behind this, you can just say tan diameter. The relationship between the tangent and the diameter, they're perpendicular. Hence, this angle here will be 90. That angle will be 90. Calculate the size of angle P. Where the hell is angle P? Okay, P is that one, né? Okay, how can we do so? We need to first find the size of the whole of angle S. Okay, how can I do that? We know that angle S is equal to, why am I saying S1? Okay, angle PSR, let me call it like this, is equal to R1, which is 48 degrees. Why? Because of a tan chord theorem. Are we together? Tan chord theorem simply states that the angle between the tangent and the chord is equal to the angle subtended by the same chord. Are we together? We can see that this chord TR has an angle between itself and the tangent of 48 degrees, and the same chord TR subtends an angle of PSR at the circumference. Simply means 48 here, and it's also 48 there. All right, together. Okay, now we know the value of angles there. I know we have 48 here. I have 90 degrees here because of tangent and radius. I can find the size of angle P. How can I do that? I can simply say angle P plus PSR plus PRS, they should add up to 180. Sum of angles of triangle PSR. Alright, together. I want to know the size of angle P. I know the size of angle PSR. It's equal to 48 degrees, and PRS is 90 degrees because of tan radius. Therefore, the size of angle P is equal to 42 degrees. So to answer this question, simply say P is 42 degrees. Okay, now I'm asked to find V1. How can I find V1? The size of angle V1. The size of angle V1. Okay. I know that R2 and V1 are the same. Why? Because they're angles in the same segment. They are subtended by the same chord TR. Ne? TR there in green will subtend the angle V1 at the circumference, and TR will also subtend angle R2 at the circumference. So we can conclude that V2 and R2 are equal because they are both angles in the same segment. So if I can find the size of R2, I can therefore find the size of V1. How can I find the size of R2? I know that R1 plus R2 should give me 90 degrees. Why? Because of the relationship of a tangent and the diameter. All together. The value of R1 is 48 degrees. I don't know R2. Therefore, R2 is equal to 42 degrees. Now I know that R2 is 42 degrees. I can simply say that, therefore, V1, which is equal to R2, is also 42 degrees. Why? Because these two angles are angles in the same segment. All together. So V1 is also 42 degrees. Now I'm asked to prove that angle PQS is equal to angle VTS. PQS. What is PQS? PQS is equal to VTS. Okay, how can I do that? Let me erase here. You can pause the video and try it on your own, guys. It's cool. I prefer students who attempt things first. Okay. PQS. I'm supposed to show that Q1 is equal to VTS. Q1 is equal to VTS. Okay, this one here. No, man. VTS is this angle. Yeah, VTS is that angle. Okay, if I can find angle S1, I can simplify the size of angle VTS and PQS. Okay, how can I find S1? How can I find S1? Now I already know that the size of this guy is 42 degrees and I have a 90 degrees triangle here. Oh no. Let me erase this. S1, how can I find S1? S1 is equal to angle T2. Are we together? Okay, it's fine. I know that S1 is equal to angle T2. These are angles in the same segment. Are we together? Both of them are subtended by what? Both of them are subtended by this arc over here. Arc SR subtends angle S1 at the circumference. The same arc subtends angle T2 at the circumference. Are we together? Please remember that the arcs will subtend equal angles at the circumference. So these are angles in the same segment. Okay, let's continue. This thing simply means that this entire angle S, they said it's VTS, right? They named it VTS. Okay, VTS is equal to T1 plus T2. This is a fact. I can simply say VTS is equal to 90 degrees. I know that T1 is 90 degrees. Why? Because T1 is subtended by the diameter at the circumference plus whenever I see T2 I can put S1. Why? Because T2 and S1 are the same. So this is the size of angle VTS, right? So now you must find the size of angle PQS, which is Q1. Okay, how can we do that? We know that Q1 is an exterior angle of a triangle. We have a triangle there, PQR, and that's the exterior angle. This thing simply means that this angle here is equal to the sum of the interior opposite angles. Are you together? So I'll simply say PQS, which is Q1, is equal to angle PRS plus angle S1 exterior angle of triangle. What's the name of the triangle? It's QSR. QSR, right? So now I know that this is an exterior angle of triangle QSR. I know that angle PRS is equal to 90 degrees. Why? Because of tan radius. So I can simply say angle PQS is also equal to 90 degrees plus angle S1. So we said VTS is 90 degrees plus S1, PQS is 90 degrees plus S1. This thing simply means that P, Q and S is equal to VTS. The reason can simply say both angles are equal to 90 plus S1. We have proven that. So now we've shown that these two angles are equal. I believe there is another way, guys, to do this. You can do it on your own. Okay, 6.2. We are told that in the diagram below, the bigger circle has points EOC and D on its circumference. O is the center of the smaller circle. C is the point of intersection between the two circles, and A and F are two more points on the circumference, okay, of the circle. ABCD and BOEF are straight lines. Okay. Whenever we are told about that, whenever you're told that a circle has a center, there are two theorems that should click in our mind. The first theorem is the one that says the angle at center is 2 times the angle at circumference. The second theorem that should click in our mind is that the line drawn from the center should be perpendicular to the chord. Are you together? So in this case, the known angle is angle A, which is at the circumference. It simply means we can find angle O1. Are we together? By just using the theorem that says angle at center is 2 times the angle at circumference. Are we together? So here I can simply say angle O1 is 2 times angle A, which is equal to 2. Let me write this in different ink. 2 times 66 degrees, which is 132. But I don't have to write this. Let me just write is 132 degrees. The reason I should just say angle at center is 2 times angle at circumference. Okay, are we together? What else do I know? I also know that angle C1 is equal to angle E, which is 42 degrees. Why? This is an exterior angle of a cyclic quad. Cyclic quad COED. Alright, together. We have a four-sided shape, and our bigger circle touches all the vertices of that four-sided shape. They don't have to tell us that it's a cyclic quad. It is a cyclic quad. Alright, together. So if it's a cyclic quad, it simply means that this angle and this one are equal, because it's an exterior angle of a cyclic quad. Are we together? Okay guys, I'm finding all these angles. Why? I'm finding them simply because I'm asked to prove that these two are equal. AB and BC are equal. Are together, and they can only be equal if I can show that angle B2 is 90 degrees. Why? Because there is a theorem that states that a line drawn from the center perpendicular to the chord should bisect the chord. Are together? So if I can show that B2 is 90 degrees, I can therefore conclude that AB is equal to BC. Okay. Now I have the size of this angle. It's 132. I have this size as well, 42. So I can find the size of B now. Why? I can say that O1 is equal to angle B2 plus angle C1. Let me erase this. Why is this thing true? It's true because O1 is an exterior angle of triangle OBC. Are we together? I know that the size of O1 is 132 degrees. The size of C1, we just found it to be 42 degrees. But I don't know the size of angle B2. Simply means that angle B2 will be 132 degrees minus 42, which is 90 degrees. So if B2 is equal to 90 degrees, I can therefore conclude that OB is perpendicular to AC. Why? Because angle B2 is 90 degrees. Are you together? So if I've proven that B2 is 90 degrees, I can conclude that angle AB is equal to, not angle AB, AB is equal to BC. Why? I'll just write the theorem. The line drawn from center perpendicular to the chord AC. Then I'll write them. OP is the line, and that line is perpendicular to AC. That's my reason. Right, together. So now I've proven that AB is equal to AC. Okay. I'm tempted not to do the proof because I want to make a video doing the proofs. Okay, but let me just do it. Whenever you prove theorems, you must always construct lines. In this case, we are supposed to show that this angle is equal to this one. Right, together. How can we do that? We can do that by firstly constructing a diameter. Right, together. We construct a diameter and then we construct a chord. The diameter will be SO. Let me call this point A. Right, together. Call that point SOA, and then I'll name this one S1, S2, T1, and T2. Okay. Whenever we prove theorems, guys, we might use other theorems to prove the theorem. Are we together? Firstly, I'm supposed to prove its unchord theorem here. Okay. I can use the 10 diameter first, and I can use the theorem that states that the theorem is cyclic quad about angles in the same segment. Are we together? So please look at this. Angle S1. Okay, firstly I need to state that UV is perpendicular to AS. This is tan diameter. Are you together? It simply means that S1 and S2 should add up to 90 degrees. Are you together? S1 and S2 should add up to 90 degrees. Which other angles add up to 90 degrees? Okay, angle T, angle A, TS is equal to 90. Ne? This is an angle in the semicircle. Angle in a semicircle. So I can therefore conclude that angle A plus angle S2 plus ATS, they are all equal to 180. Sum of angles of a triangle. Ne? I'm lazy to write everything, but please write the complete reasons when you do it. This thing simply means that angle A1, angle A rather plus S2 are both equal to 90. Are you together? I have an angle plus S2 and then I get 90. Even here I have another angle plus S2 equal to 90. Angle plus S2 equal to 90. Simply means that angle S1 and angle A1 are equal. Angle S1 is the same as angle A. I can write that both of them are equal to 90 minus S2. Are you together? However, angle A is equal to angle R. Angles in same segment. No, here it was not S1, it was not S2, guys, it's S1. Ne? Excuse me, I indicated S1 and A that they are equal. Okay, I also know that excuse me, I also know that angle R and angle A are equal, ne? Because of angles in the same segment. So I can therefore say that angle S1, which is angle VST, is equal to angle R. Then I've proven the tan-chord theorem. Okay, I'm told that LG is a tangent to circle EFGHP at G. Okay, chord PH is produced to P. Chord HF cuts GP in M, and chord EG in K. We are told that there are parallel lines there, EG and PL. EF and PH are equal. equal chords subtend equal angles, guys. Remember that. G4 is equal to X. Okay. Write down with reasons 3 other angles which are equal to X. 3 other reasons, 3 other angles, man, which are equal to X, ne? This angle here is X because of time-cut theorem. Right, together. So I can simply say angle P is equal to angle G4, which is X time-cut theorem, ne? And you can simply state that angle F2 is also equal to G4, which is X. Same reason, time-cut theorem. And then angle G2 is equal to angle P, which we know that is equal to X because they alternate. And they're alternating because EP is parallel to EG is parallel to PL. EG is parallel to PL. So I've written 3 other angles with reasons that are equal to X now. I'm supposed to show that triangle HMG is similar to triangle EFG. Is similar to this one. Okay. How can I do that? Okay, firstly, guys, I know that there are angles there which are subtended by equal chords at the circumference. Another one is that another one is that let me see another angle. Okay, let me write. I was told that EF is equal to PH, ne? Which simply means that angle G1 is equal to angle G3. Why? Because these angles are subtended by equal chords. Together, if 2 angles are subtended by equal chords, therefore those angles should be equal, guys, ne? And I also know that let me write this first. In triangle HMG and triangle EFG, ne? G1 of triangle, let me write them like this. That means I'll have, for HMG I'll have G3, and then for EFG I'll have G1. Okay, these two angles are subtended by the same chord. I'm comparing two triangles that are similar, right? I can also say angle H2 is the same as angle what? As angle E. Why? These are angles in the same segment. If we can check properly, both of these angles are subtended by chord EG. This is the first one, H2. That's the second one. Are we together? So I can therefore conclude that the whole of angle F is equal to M3. M3 is equal to angle F. Why? This is the third angle of a triangle. So I can therefore conclude that triangle HMG is similar to triangle EFG rather. To triangle EFG. The reason is angle. Let me write at the bottom. You must always write the reason, guys, whenever you prove similarity. Né? This is the reason. Angle. Then, hence or otherwise, show that PH over HG is equal to that. When they say hence, guys, they mean that prove what you've just proved. Use what you've just proven to show this thing. Okay, I know that. Okay, firstly, I've proven that G3 is equal to GH. Né? Okay, G3 is subtended by what? By HM. G1 is subtended by what? By EF. Right, together. And then I've shown that H2 and E are equal. H2 is subtended by GM. Né? And then angle E is subtended by FG. Okay, these are corresponding sides, guys. If you are struggling, please listen to lesson 25. Yeah, it's 25 if not 26, whereby I talk about similarity and proportionality. You'll understand why I am doing this. Are we together? I'm taking the sides which are in the same proportion now. Okay, and then we have angle M3 subtended by GH. We have angle F subtended by EG. So what are we supposed to prove? We are supposed to show that PH multiplied by HG is equal to EG times HM. EG times HM. Okay, here, guys, I'll simply need these two together. So can I write on the left hand side? I'll say HM over EF is equal to GH over GE. Né? And the reason here, guys, I was supposed to say these statements are true because triangle HMG similar to triangle FG, ne? Okay, I can just cross multiply here, guys, ne? I'll have a GE multiplied by HM equaling EF multiplied by GH. Right, together. I do have GE and HM. Here are they. HG, here it is. I don't have PH, but I have EF. Remember that EF and PH are the same. So whenever I see PH, I'll simply write, whenever I see EF rather, I'll simply write PH. So there it is. I've proven that this is equal. Okay, I am given I'm given a figure there, ne? I'm told that in the diagram below, triangle ABC is drawn with D on BC and F on E, F and E on AC. Okay, such that we have parallel lines there. We have parallel lines, okay, and perpendicular lines. Told that this length is 6, this one 6.5. Okay, we must find AB. Triangle ABC is a right angle triangle, right? You can simply say AP squared is equal to AC squared minus BC squared, ne? Pythagoras theorem. This is the theorem of Pythagoras, guys. Okay, so I can just say the square root of 6 squared, of 6.5 squared rather. The square root of 6.5 squared minus 6 squared. What will I get? 2.5. AB is equal to 2.5. Let me write here. AB is 2.5 units, ne? AB is 2.5 units. Okay, prove that CB squared is equal to the square root of, let me erase. Prove that CB squared, where is CB? Okay, the square root of CA and the CE. Okay, I can say that in triangle ABC, and triangle BCE. Why am I choosing these two triangles? It's because here I'm supposed to prove something that has the length of CA and it has the length of CE together. There is a triangle that has CB as a common side together. So if I take triangle, if this is my common side, let me show it in red. If this is my common side together, B appears on this triangle, and BC also appears on the bigger triangle. So that's why I'm using those two triangles to prove that together. So the first thing that I know is that angle C is common. angle C is a common angle, right? What else do I know? I know that angle B from the other triangle is equal to angle E. Why? Both of them are equal to 90 degrees are together. So that will make angle A to be equal to angle B of the other triangle, this one. Are together. Let me say EPC. This is the third angle of triangle are together. So I can therefore conclude that triangle ABC is similar to triangle BCE. Angle, no? Okay, and then now with the ratios, angle C from triangle ABC is subtended by what? By AB. Angle C is subtended by EB, right? And then we went to angle B. Angle B is subtended by AC. And then angle E on the other triangle is subtended by BC. Okay, and then I have angle A. A is subtended by BC, and then angle EBC is subtended by what? By CE. So these are the only things that I'll need together, and this thing is true because of similar triangles, né? So I can simply state that AC over B. No, why am I writing it twice? Since this is the only thing that I need, I'll simply remove this one and just cross and multiply here, and then I'll have BC squared is equal to AC times CE. Then if I take a square root both sides, I'll be left with BC is equal to the square root of AC and CE. And then I'm asked to find the length of CE. How can I do so? BC is equal to AC. Please note that BC was given as 6 units. AC is 6.5. I don't know the length of CE, né? So therefore CE will be equal to 36 divided by 6.5 to 5.54. It's 5.54 units. Let me go right there. What's your decimal place? Okay, write down the length of AE. Oh, okay, simply means that AE is 1, né? Remember that the length of AC, let me write here, the length of AC is equal to AE plus CE, né? AC was given as 6.5, AE we just found out to be 5.5, simply means that CE is 1 unit. All together. AE is 1 unit. So I'll simply write this is 1 unit. Okay, now I'm asked to determine the length of EF. The length of EF. How can I do so? Okay, let me use the eraser to create some space here. Okay, they want me to find the length of EF, right? What do I know? I know that how can I find EF? Okay, I know that BC over BC over D over BD is the same as AC over AE, ne? This thing is true. I'll write the reason in black. It's proportionality theorem, ne, guys? And the proportionality theorem is true because AB is parallel to ED. Are we together? Okay, secondly, I know that BC over BD is also equal to CE over EF. Same thing applies here. It's the prop theorem. Are you together? But now the reason is because EB is parallel to FD. EP is parallel to FD, ne? So therefore I'll simply say that AC over AE should be equal to CE over EF. Why? Because both ratios are equal to BC over BD. Are we together? I know that AC is 6.5 units, AE is equal to 1, CE, I found CE to be 5.5, and then I can find the length of EF. I can find the length of EF. Together, I can simply say 6.5 multiplied by EF is equal to 5.5. So therefore, EF will be equal to 11 over 13. Okay, guys, that's how you answer geometry, guys. Ne? I was doing the KZN paper 2, which was written in June. This video, I'm sure it's lengthy, but please, guys, be patient. Everything I've said here is important and fruitful. Thank you for your time.